Hello, my name's Ayub. My student number is S400152, and I'm demonstrating my database for the flying parts circuit business. This business requirement was to move from manual, disconnected records to a robust relational system. I have developed a SQL Server backend with a Tableau front end to provide real-time decision support. Before we look at the data, let's look at the ER diagram. The database is designed to manage the main operations of a business that sells aircraft parts, including employees, customers, inventory, suppliers, and sales orders. The first section that we have is the employee and department section. The department entity stores department information such as department ID and department name. This is connected to the employee entity, which is one of the core tables in the system. The employee table stores general employee details like employee ID, name, address, phone, salary, national insurance number, and department ID. The department ID is a foreign key. This means each employee belongs to one department, while one department can have many employees. Then the employee entity is specialized into three subtypes. We have admin, we have technical support, and we also have sales representative. This shows that different employees can have different roles in the company. For example, admin includes attributes like title and bonus, and technical support has certification area, and sales representatives has commission rates. This helps the system store role-specific information without repeating employee data. In the center of the diagram, we have the parts entity. This is very important because it stores all aircraft part information, including part ID, description, unit price, quantity in stock, and minimum stock level. This allows the business to track inventory and know when stock is running low. The aircraft model entity stores aircraft models details such as model ID, manufacturer, model name, and year. Since one aircraft model can use many parts and one part can belong to many aircraft models, this is a many-to-many relationship. That's why we use the bridge table part aircraft model, which connects parts and aircraft models. Next, we have the supplier section. In the supplier section, we have a supplier entity which stores supplier details like supplier ID, supplier name, and contact info. A supplier can provide many parts, and a part can also come from multiple suppliers. So again, this is a many-to-many relationship, and it is resolved using a supplier part table. This structure helps the business know which supplier provides which part. The next section that we have is the sales and the order section. In the sales order entity, we have a order number, the date of the purchase, the shipping address, the billing address, the status, the total VAT, the total cost, and also we have a foreign key that is customer ID and a foreign key that is a sales representative ID. So this means that one customer can place an order and one sales representative can handle the order. A customer can have many sales orders. Each sales order belongs to only one customer. The order line table stores the individual items inside each order. It includes an order number, the part ID, a quantity, and a price at sale. This is necessary because one order can contain multiple parts and one part can appear in many different orders. So this resolves another many-to-many relationship between sales order and part. Finally, the customer entity stores general customer details like customer ID, name of the customer, the address of the customer, the phone number of the customer, and the default shipping address. We also store the latest purchase date and also the latest payment date. This is also the customer entity is also divided into two sub-entities, which is the retail customer and a wholesale customer. This allows the business to store different type of information depending on the customer type. For example, a wholesale customer might have different related details such as a PO number, a discount, a tax status, and a customer and a contact person. And retail customers have different details like card number, card type, expiry date, and email. So overall, the ER diagram is designed to support the full workflow of an aircraft parts sales company. It helps manage staff and departments, aircraft parts and inventory, suppliers, customers, and also sales orders. The use of specification and bridge tables make the table more organized, flexible, and efficient. For this part, I'll be doing 5 different queries. For my first query, I wanted to show the employee details of the sales representatives with the highest and lowest total number of sales orders. To do this, I used a CTE called rep sales, which joins the employees, sales reps, and sales orders tables. The query then uses the count function to calculate how many orders each sales representative has handled. After grouping the results by employee, the final part of the query filters the data to return only the sales reps with the maximum and minimum total number of orders. This query is useful because it helps the business compare sales staff performance and identify both top performing and low performing representatives. So now if we were to run the query, we'll see that there'll be two rows. There'll be two rows. First one being the highest performing representative with 4 total orders, and the second one being the lowest performing representative with 0 orders. For my second query, I wanted to show the number of sales orders for each order status. This query uses the sales orders table and selects two things, the order status and the count of orders in each category. I use the count function on the order number to calculate how many orders exist for each status, such as pending, shipped, and completed. Then I used group by order status, so the results are organized based on each order status. This query is useful because it helps the business monitor the progress of orders and quickly see how many are still pending, processed, and completed. So now if we're to execute it, we can see that we have 3 cancelled orders, we have 13 completed orders, and 4 incomplete orders. This third query is used to show parts that are low in stock along with their suppliers. It joins parts suppliers, and suppliers tables to connect inventory data with supplier information. Then it filters the results to only show parts where the quantity is in stock is below the minimum stock level. This is useful for inventory management because it helps the business know what needs restock and how to order it from and where to order it from. So here we can see that the main rotor blade, there's 2 quantity in stock and it is below the stock level, and the supplier name is Global Aero Parts, so we know exactly where to supply the part from. This fourth one is a trigger called TRG Auto Reorder, and it is used automatically. It is used to automatically monitor stock levels. It runs after a part record is updated in parts table. If the new stock quantity falls below the minimum stock level, it generates an alert to indicate that the part may need to be reordered. This is useful because it adds automation to the system and it helps improve inventory control. So this is the SQL that I did use to create the trigger earlier. So now if I do use this other SQL to pause the trigger, you can see here on the top that it says alert stock level critical reorder initiated for part. So this last one is a stored procedure called SP generate invoice, and it is used to generate an invoice for a selected order. It takes an order ID as input and then joins the sales orders, customers, and order lines and parts tables. The procedure returns all the imported invoice details, including customer information, ordered parts, quantities, prices, VAT, and total cost. This is useful because it automates invoice generation and makes order processing more efficient. So this is the SQL that I did use earlier to create this procedure. So now if I do use this command, oh, sorry, let me just get the command. If I do use this command to generate the invoice for 1001, you can see that the invoice is created for this exact order that contains the order number, the order date, the customer name, part name, the quantity, the price at sale, the line total, the VAT total, and the total order cost. For the final part of my project, I created 5 visualizations in Tableau to present the data more clearly. These charts help turn the database information into useful business insights for business decision making and performance monitoring. Starting with our top earners chart, we are looking at a total revenue generated per sales representative. You can see Kelly Rose and David Black are our leading performers. This isn't just a leaderboard. It allows management to see which staff members are handling our high-value aircraft parts It ensures our commission structures are driving this right sales behavior. This second dashboard visualizes inventory risk by showing the quality in stock for each part. Using a color gradient from red to green, items in red represent low stock levels and higher risk, when green indicates higher inventory. The chart makes it easy to quickly identify which components, like the alternator or cockpit window, may need restocking, helping teams prioritize inventory management decisions effectively. Our third chart is our order health chart. This chart tracks our order health. While the majority of our 20 orders are complete, the red bars show incomplete or cancelled orders. By clicking these in Tableau, we can see they correlate directly with the stock shortages we just identified. It provides the inventory issues are having a direct negative impact on our fulfilled revenue. Our supplier dependency tree map shows our sourcing mix. The large orange block shows that Global Aero Parts provides nearly 40% of our inventory. From a risk management perspective, this tells us we are heavily dependent on one vendor. To protect the business, we are using this data to shift more orders toward our secondary suppliers like Avonix Direct. Finally, we have our best sellers. Navigation lights are our highest volume item by quantity. This is a vital insight because it tells the warehouse team which items need to be closest to shipping dock. It also tells us that even small, inexpensive parts are core to our daily transaction volume and must be kept in stock at all times. The flying parts circuit database system successfully replaces manual processes with a robust automated relational solution. By implementing a normalized schema, the project has established a single source of truth that ensures 100% data integrity across all inventory and sales transactions. Through the integration of advanced TSQL triggers and Tableau visualizations, the business has moved from reactive to proactive management. The system now automatically identifies red zone stock risks such as main rotor blade shortages and the moment they occur, protecting revenue and improving customer fulfillment rates. Ultimately, this project demonstrates how bridging the gap between raw SQL data and visual storytelling creates a strategic asset. Flying Part Circus is now equipped with the scalability and data-driven insights necessary to optimize its supply chain and maintain operational excellence in the aviation parts industry.